If you are working on Kubernetes development, then sooner or later you definitely have to write the custom controller or CRDs. In this session, we will cover how to create a custom CRD and how to create a custom controller for that CRD. Hi, my name is Pramod Bindal and I'm working as a principal software engineer with Red Hat. Before we start, we expect that you are already aware about the CRDs, that is custom resource definition. In this course, we will cover how to create custom resource definition, CRDs, CR, and a controller around that. Very first step towards this exercise is creating a new project. I'm using a Golang editor. You can use any editor of your choice. There is no mandate of using Golang. This is the name I'm giving to my Golang project, and in this project we will create a CRD. We will also create a custom controller around that CRD. And yes, when we are creating a CRD, definitely we want to set some objective around that. So keeping everything simple, we won't be creating a very complicated CRD right now. The CRD will define the set of labels, and the controller will watch the CRD resource as well as the deployments, and whenever there is any new deployment created, it will automatically apply the labels defined in CRD. Okay, so that is the whole objective of this exercise. So first thing towards is like we create a Go module. Right now it is mentioned as my custom controller, so it's recommended we keep it something domain specific. So github.com Pramod Bindal and my custom controller. This is my Go module. There is a main.go generated by Golang itself. We won't be needing this Golang, but for now let's keep it. It will help us compiling the project. We are going to create the custom controller here using Knative framework. So to start with, let's create a custom resource here, and to for the custom resource we will create a directory called pkg APIs. Okay, and in this APIs we will create a direct Go file called types.go. Okay, and in this types.go is basically defines the structure of our CRD. As I already mentioned, our CRD is custom labeler. So let's name the CRD like type labeler labeler struct. Okay, this is our type, and what all it will have. For that we need to add some import statements. Import meta v1, this will be the import statement. To add this import into types.go, we just do go mod tidy. Sorry, the package name is this. Yeah, now it's imported. So let's set up meta v1.types meta. That will be one field. Wow. So there will be two default fields. Every Kubernetes resource should have these fields, and now we will have another field spec and labeler spec. Okay, and then JSON will be spec. And now because we are using a custom resource here, then we have to define this one as well. Then the type label spec, and then the label spec is basically the specification that we want to have inside this custom labeler. And because our resource is very simple, we will just define what all labels we want to apply on deployment. So let's keep it simple. We will say custom labels, okay, and it will be map string, nothing else. And apart from that, we need another resource called. So this code is like the suggestion is very fast from this Golang. That is the reason I use Golang editor. User facing resources, whenever we define, we need to define type meta, and because labeler is direct object, so it will have the object meta. Labeler list is list of labels, so for that it is using list meta. And items, list will always contain items. So that's all. Resource definition is complete. Next step is to generate the boilerplate code around that. To make Kubernetes understand, to the code generation API understand what all we need to generate. So first thing, we need to add some annotations. So because our base type is the labeler, so we will add these annotations on labeler. So the what it says, it is gen client, so that means it will generate the client. KATS deep copy gen, it will generate the deep copy gen, and it will assume the interface for this object is API machinery KPI API machinery package runtime object, and it will also generate the resource. It will also generate the reconciler, and we are keeping kr shift logic equals to false. Kr shift logic requires some additional implementation in the object, but which we don't need right now. We will discuss about that in some other videos, but yeah, for now we need to these 4 annotations on this object. And apart from that, the deep copy annotation we need on the labeler list as well. Like any object that we want to register to Kubernetes, that should have this deep copy annotation. Okay, so that is one thing. Sorry, I did one thing wrong here. In under the APIs, we need to define additional structure that will be group name and package name. So package name will be v1 al alpha 1. Okay, so let's move it to here. Nothing fancy. Okay, so now the package name is v1 alpha 1. And now, okay, so inside this v1 alpha 1 we will have another go file called doc.go. This is just to define the package level annotation. These annotations are read by the Kubernetes generation API, and it requires 2 annotations. Okay, one is the deep copy gen as the package level, and group name. What will be the group name of our custom resource? That will be the pramodbindal.dev. You can keep any group name of your choice. Just do remember your resource will be registered with this group name only. So whatever you choose here, the resource will be registered with this group name only. Okay, now I think it's good time to generate the code. Okay, so to generate the code, we need some additional scripts. We don't need to write these scripts. These scripts are readily available on the Kubernetes site. I'm just copy pasting those scripts here. I'll walk you through about what all we have done. Some minor changes we have done in the script. That's a custom boilerplate go.txt. It is nothing. It is like whatever it is. Like I just mentioned like copyright 2025 Pramod Bindal, and then tools.go. Tools.go will define the libraries used by code generation package, so we don't have to worry about them. These are already part of the tools.go that we get from Kubernetes. Okay, and we don't need these 2 scripts at least for now. And then third one is the update codegen.sh. In update codegen.sh, so this update codegen sh is the main script that will generate the boilerplate code. It has 3 function calls. One is the gen helper. It will generate the helper functions. Gen client, it will generate the client functions, and there is additional function call for Knative APIs. This will generate the Knative specific code. So let's see what happens. Okay, so what we need to hack update code gen.jsh. Okay, because we just added a tools.go, but these libraries are not yet added in the go.mode. So what we need to do is go mod tidy and go mod vendor. Remember, whenever you update any of your libraries, you add or remove, just make sure to run these 2 commands so that the libraries becomes part of your go.mod and the vendor directory. So let's run it again. Another requirement, the update code gen.sh we are using is from Knative. So if you see, we are using the Knative update code gen, and it requires that whatever repository you are working on, it should be a Git repository. So let's make it a Git repository. While nothing, I don't have to. So just say share project on GitHub, my custom labeler, and share. Okay, then let's say custom labeler. Okay, now repository is created. Okay, and we need to do everything now. No need to commit or do something more. It is just we will have the .git directory after doing this, and this should be enough to generate the code. Code generation will take some time, but yeah, we can wait. Okay, so code generation is complete, and to make sure to verify if my code is generated properly or not. So first thing, inside the v1 alpha 1 package, that where we are types are written, there should be a file generated called zgenerated.deepcopy.go. Apart from that, there will be also additional directory called client at the API's level, and it will have client chat informers, injection, lister, and injection will further have client informer and reconciler. Okay, so that means our code generation is complete. Now we can proceed with next step. Now when our code generation is complete, that means our CRD is created, but this CRD is not yet recognized by Kubernetes. We need to register this CRD in Kubernetes. So what we can do is we can create one more Go file, that is register.go. Okay, and then let's add it, and in this register.go we need to define some functions. Okay, so the function is like one function we need to define, function add known types. Okay, so the Golang is very smart actually. It automatically suggests me what I'm trying to write. Okay, and now there is also a variable we need to define. So where this is the variable we need to define, and why do we need is because when we say scheme, okay, scheme dot add known times, and it will require the schema group version, so that we have already defined. And apart from that, we need to also give the resources that we want to register. So our resources is labeler and labeler list. Okay, done. There is one more registration we need to do, meta v1 dot add to group version, and there we define the scheme and schema group version. Okay, and now finally return nil. Okay, 3 lines only. Scheme group version is defined. Now we need a scheme builder. Scheme builder is equal to runtime.new scheme builder, add known type, the function name that we defined, that's reference to this function. And apart from that, we define add to scheme. Okay, 3 variables we need to define. In case we miss defining these variables while running the code, it will automatically give us error. Okay, this is not defined, this is not defined. Okay, and there is one more thing we need to define is resource. Okay, so resource also we will define, that is resource schema.group resource and schema group version. This is schema group version dot with resource and whatever resource name is provided as input. Okay, that's all. Now our CRD part is complete, no further action required. But that's not enough. By using this, we can just create the CRD, but we won't be able to utilize the CRD until there is a controller around that. Now as our CRD code is done, let's generate the CRD YAML. And to generate the CRD YAML, we have a predefined command called controller gen CRD, and the paths is equal to like wherever you have defined your API. So I am giving the reference to dot slash triple dot and output CRD artifact config, where you want to generate the configuration, that will be config slash CRD. So I'm giving this directory. Okay, and because this directory is not present, let me create this directory first. Config CRD. Okay, now let me see. I'm expecting one CRD resource must be generated inside this directory, but no, because we just defined some more resources. Okay, so let's do the go mode tidy and go mode vendor. Okay, now let's see, try it again. Okay, so the error is encountered struct field custom labels without JSON tag in type labeler spec. Okay, let's see what is the problem in the types.go. Yes, you see the custom labels is defined, but JSON spec is not defined. So like every field that we are defining in this types should have corresponding JSON annotation. So yeah, now it should be okay, but because we have changed this, let's generate the code again. Now let's try controller gen. Yeah, this time it is successful, and we have this labeler generated. Now next step is to write a controller around this. So before writing any controller, let's deploy it on Kubernetes. kubectl get ns. Let me see if Kubernetes is connected. I already have the kind cluster here, that's why it is showing me the namespaces and all. So to use this, you must be having a Kubernetes cluster ready. And now to apply this kubectl, apply -rf config. Now I have applied the configuration so that this is generated. Let's see if my CRD is created. So OC get CRD. Labelers.pramodbindal.dev, this is the group version of my CRD and it is created. Okay, now let's create the resources, sorry, the controller. And to create the controller, what we need to do is we need to create a directory called cmd labeler. So this is how I create, so that like whenever we want to have multiple modules in same directory, we can do that, but otherwise it's not mandatory to follow this structure. The labeler, and this labeler we have to create a go file called main.go. Okay, and then add. Okay, labeler. Now because it's a main file, we need to write a main function. Easy. And in main we need to import. Now let's import knative .dev package injection and shared main. To add this shared main into library, we need to do the go mode tidy, and once that is done, it will automatically show it is like unused import. Okay, shared main dot main. Okay, and in this shared main dot main, if you see the definition, it says you defined the component, and then with this component you can define the controllers, any number of controllers. So the main, let me define the controller name is custom labeler. Okay, and then controllers. So right now we don't have any controller. Okay, so let's create a new controller. So for that I'll write a new file called controller.go. It's not difficult, but yeah, so it's easy here when you say new controller, and by doing this it will say create function new controller. Okay, and this will be the signature of your controller, and you can define this function here. In Golang, it doesn't matter whether you define this function in controller.go, main.go, or xyz.go. If the function is with the file is within same package, the Golang is able to read that function without any import. Okay, so now we just need to do return nil. Okay, now see main dot, yeah, so main implementation is complete. Now whenever we deploy this controller into Kubernetes, it will call the new controller, and from this new controller, currently we are returning null. We need to define our exact controller definition. Okay, so let's start this controller definition. Controller for this, let's start with the logger. So logger equals to logging.from context, and the context that we are getting. Okay, then what we need, the list of labels, the label, the CRD that we have created, we need the information about that labeler. So for that we say label informer, and for the label informer we need to add a import statement. So label informer, and the import statement will be alpha1 and then labeler. Okay, and this labeler, what we need to do is labeler dot get and ctx. Okay, so this is how we get, and let's name it differently. So package name we keep it on small case, and this will become our label informer. Okay, and because we are going to apply these labels on a deployment, so let's import the deployment informer as well. Deployment informer. Now deployment is not a custom resource, so it will not come from our local repository. It is already defined in the Knative. So let's import from the Knative deployment. Okay, and then again we will do the same for this. Deployment informer equals to deployment informer dot get and then ctx. Okay, now to add this, let's do this again. Go mod id we have done. Now it should be able to get it. Now let's add a logger statement. Logger dot info. Okay, setting up event handlers. We need a reconciler. What is reconciler? Label informer will give us the information about the labeler. Okay, sorry, let me name it properly. Labeler informer. Same way the deployment informer and the deployment informer will give us information about the deployment. Now we need some kind of logic which will read labels from label informer and update the deployment. So that is called reconciler. Okay, so let me create a reconciler resource now, and for now I'll create the reconciler object here only, but we will move it to the reconciler.go because it's always good to have the reconciler in its separate file. So type reconciler struct and what all it will need. So same way like we have defined here, let's put everything in the reconciler. So we'll say reconciler equals to, not this way, we'll say reconciler. Okay, now fields, label informer, okay, deployment informer. Okay, and then additional object we will need is the kube client. Kube client is basically we need a client to interact with the Kubernetes APIs. So that's why creating a kube client as well. Now this is all we have defined, like this is all we need inside reconciler. So let's add them into reconciler object. Okay. Okay, done. Now it's okay, this is done. Now time to create a controller. Okay, so controller, we need to return the controller impl. So let's see, impl equals to, we create, so to create a controller we need the, just like the label informer we have, we need a label reconciler as well. So labeler reconciler, reconciler. Don't worry about like the terms that I am using. After this controller is done, I'll just summarize whatever I have done. So instead of like informer, it will be reconciler, reconciler. Okay, and then label reconciler dot new impl. Okay, what it will take, first parameter is the context will go, and then reconciler, that object that we have created right now, and then it will take a function as well. Function will be the controller impl and it will return the controller options. Okay, and then we need to define, like we need a controller option, so return controller dot options. Okay, and the controller options, so we can define like escape status update equals to true, like whatever controller options you want to define here, it will do. Now the reconciler we want to return this the implement IMPL that we have created, that we will return to the caller. Now it is giving an error saying that we cannot use reconciler here because it do not implement the function called reconcile kind. Okay, we can simply go ahead and implement this function here, and by implementing this function it says like a context we have and the labeler. Let's rename it labeler. Now most of the work is done. We have the labeler here. All we need to do is we need to get information from this labeler and apply this information on the deployment. So panic, okay, we want needed return nil. Okay, so just like earlier we need to create a logger. Okay, then logger.info reconciling labeler and labeler.name, that labeler whatever is passed. Now we have the labeler, we have added a logger. Now I think it's a good time to move it from its own file. So reconciler dot go, okay, and that here, move it from here to here. Now what all need to do is first get list of deployments, okay, and then apply labels, right? That's all we need to do. So to get list of deployments, we already have the deployment informer here. So what we'll do, r dot deployment informer dot lister dot list, and which all labels dot everything. So if here we can filter out what all deployments we are looking for, but let's have all the deployments. Okay, easy. Next is to apply labels on each of these deployments. So deployments, let's loop through these deployments. Okay, and then what we need to do is we need to first create a patch data. Okay, because whenever we try to update any resource in Kubernetes, and any, just like the one controller that we are writing, there might be some other controller already written for some other purpose, and that controller might be also updating the deployment. So in that case there will be a conflict. So instead of updating the deployment, it's safe to create a patch. Let me create a patch. So before updating the labels, so for the patch we need a patch data. Okay, patch data equals to map string interface. So this structure will be similar to what we have inside Kubernetes. So it will be like it is kind of metadata. Okay, so metadata is what? String and then object, and inside this object we have metadata and then interfaces. Okay, and then in this metadata we have labels, and the value of labels will be, we already have the reference to labeler. Okay, labels dot spec. Don't be confused with label dot labels, because these are the resource specific label that Kubernetes supports, but we are not looking for these labels. We are looking for labeler dot, why it is not giving me spec? Okay, sorry, I should have access to spec. Okay, the reason is I used, by mistake I use a small case s, and whenever we use the small case s, it will not be accessible outside the package. Okay, so that is the reason. And now labeler dot spec dot custom labels, again same issue. See, it should variables should be capital case only, spec dot custom labels. Okay, it is created now. Now what we need to do is we need to apply this patch data on all the deployments. So let's say patch JSON equals to JSON dot Marshall, and it will, I'll give the patch data. Okay, and it might give the error as well. So error, okay. So now if if error is equal to null, then we'll say okay, there is some problem with the Marshall. Otherwise we have this patch JSON, and this patch JSON we will use to update the deployment. Okay, to patch any deployment, what we do, r dot kube client reference we already have. Okay, and then apps v1. Okay, apps v1, we will go to the deployment. Okay, dot deployments, deployment from where, deployment dot namespace, our deployment namespace, and then patch context we provide deployment dot name, we already have the deployment types, merge patch type, patch JSON that we just generated, and patch options. Okay, so this is all. Now our patch is applied. Okay, but this might give some error. Let's not ignore the error. Okay, so what if there is any error? If error is not equal to null, then okay, and deployments. Okay, here also, like when we are getting the deployments, error can come here as well. So let's, if it is returning any error, then if error is not equal to null, every time we get an error we have to take care of that error. So the taking care of error is basically just log it, return it, like whatever you want to do, but if error is generated we must be aware about it. Okay, that's all. Okay, there is more to do, but we'll do it once we get the error. Like if I apply it right now, it will not work, but still I want to go ahead and apply that. And to apply that we will need a deployment. Like in Kubernetes we cannot directly apply this uh, Go file, we need to create a deployment from it. So from the config we already have the CRD. Let me create a deployment. Okay, so I have created one deployment YAML file for this controller, and this is simple deployment configuration for the Kubernetes resource. We will directly jump to the spec section of this deployment, and here we have a service account name. We will be running this deployment as a service account Pramod Bindal. This deployment will have one container as well. The container name is controller, and this is the syntax to specify the image name via co, so that you don't have to build the Docker image and upload to the Artifactory. No, you don't need to do that. You can simply specify co colon and then the path to your main project. So if you see the main.go is here, so the path to this main.go we need to specify here, and that's all. Apart from that, there is one environment variable that you need to specify, that is system namespace, and the value we can read it from metadata.namespace. So that's all. Let's try to apply. What happens? So the syntax is ko apply -f config controller.yaml. Okay, it says ko github.com Pramod Bindal my custom labeler cmd labeler is not a valid import path. The import path is not package main. Let's see. Okay, so the reason is this main.go package should be main, and it is labeler, so that's why it's not working. What we need to do is we need to change it to main, and just make sure all the files in one package, one directory have the same package name, otherwise it will give you error. So you see I have changed it to main. Now let's see the error. Yeah, it's gone. Okay, so here you see in.spec is undefined. This is like earlier I used the spec as a small case character. Later on I changed it to deep capital case, but I did not regenerate the code. So I have to regenerate the code. So update codegen.sh. Okay, now let's try it again. You see it's changed to capital. It is fixed now. Now another error. Package is not used. So okay, so in controller.go there are some packages which we are not using. I don't know how these packages are added. We definitely don't need these packages. So before we apply this on Kubernetes, let's create a namespace here. kubectl create namespace labeler. Now as we have the namespace applied, now let's apply this controller. Now let's apply this controller. So it is kubectl apply -f config and then namespace labeler. Okay, it is created. kubectl labeler get PO. No deployment is created, but pod is not created. Okay, now let's see. Replica set is created. Yeah, replica set is created. Now let's see why pods are not getting created. So describe rs. Okay, because we are using the service account Pramod Bindal, but we have not yet added the service account in this Kubernetes. So that's why it is giving me error. Let me add the service account. Okay, so service account is simple. v1 kind service account metadata Pramod Bindal. Okay, so let me do it once again. All we need to do is just now to keep it faster, I'll use the R. So it will apply everything in this config directory. I don't have to specify the file name again and again. Okay, the deployment is not changed, but the service account is created. Service account not found. So let me delete this service account and create one. Delete rs. Get rs automatically created, and you see now we have the pod as well. Okay, but invalid image name. Why so? Okay, unfortunately instead of ko I used kubectl. Okay, let's see what happens now. Get po. Yeah, it's running now. We can see the logs. Logs -f error reading parsing logging configuration, because we are using Knative package, so it must have the logging configuration defined, and the logging configuration we have defined, but we have not created the logging config logging map. So let me create the map as well. We'll just keep adding resources one by one. So there is config logging. It by default it will be config logging only. Okay, we don't have to labels, we don't need. I have copied this config map from some other resources, so we can just customize as per our need. So config logging will be the name, the data, the example is optional, and the logging dot label controller, labeler controller will be debug. And let's see what name we have used for our controller. So it is in main.go, it is custom labeler. Okay, so let me change it in the config logging.yaml, and it will be okay. Now repeat it. Okay, config map is created. Get po. Delete po, so that new is created. Get po. Now logs now we have the config logging, but the service account that we are using is not having enough permissions to read config maps from this. So for that we need to create roles and role binding. Okay, and okay, now I have added role and role binding. Let's see what is the role. Let name it auto labeler role, and it will be we need to define some roles. One is the coordination. This is required by Knative. Okay, and then API groups. What all API groups we are using? Pramod Bindal dev, apps for deployment, and blank for config map. Resources labeler is our resource, deployments we will be updating, and the config maps we will be reading. Okay, and then what all verbs we need, we will be getting them, listing them, watching them, and if required we will be patching them. We also define the same roles at the cluster labels. Cluster label resources, we say pramodbindal.dev. In API group, we need the get list and watch permission, because we won't be updating the pramodbindal.dev resources. It is just we will be reading them. Then API groups apps, we will be API groups apps, we will be reading the deployments, and then also we will be updating. We don't need to define the config map at this location, because we will be reading config map from the same namespace only, so we don't need that permission at the cluster level. Just repeat the command. Done. Get PO, crash loopback off, delete PO, get PO. Okay, this time there is some error. Let's see. Invalid log label custom labeler. Okay, so config map is read, but the custom labeler is not. Okay, so by mistake what we did, we changed this, but instead what we had to do is we need to change this, not that. That will always be the debug. Get PO, delete PO, get PO. Now it's running. Let's see what are the logs. kubectl logs. Yeah, although it is able to reconcile, but still there are some error. Failed to list user system service account labeler Pramod Bindal cannot list resource deployments in API group apps at cluster scope. Okay, so we have applied everything, but still it is not able to list everything. So now it's time to review if we have right permissions, right? So let's see. So what we will do is get cluster role. So this cluster role we created. Group apps deployment, so we should be able to do everything. So apart from that, there is binding grep labeler. Okay, binding also defined. What mistake we did is, we did in the cluster label role binding, the service name service account is defined as Pramod Bindal, but the namespace is given as default. That means the permissions are given to wrong service account. The permissions are given to the service account which is there in the default namespace, not in the labeler namespace. So I'll just change it to label labeler namespace. Okay. Applying it again. Get PO is still running, so we can still watch the logs. Logs -f. There is no error. If the reconciliation is succeeded, let's me open opc get deployment. Okay, -a. I'll check the labels of all the deployments, whether the labels are changed or not. But how they will change? We have not created any CR resources. We have not defined what kind of labels we want. So for that, let me create one CR as well. Let me create the CR here, cr.yaml, and in this cr.yaml you see the kind is labeler. API version is what we have defined. Name will be example labeler. Namespace default, let's remove it so that it is created in our namespace v 0.0.0. Okay, there is no such release right now. Target resource we are not defining. Annotations we are not defining, and the environment will be production, or I'll say dev. Environment is local. Okay, label manager is example labeler, and team is DevOps. Any label that you want to specify, you can specify here. And now let me create. Okay, so first let me watch the resources. Okay, and from here I will apply this resource. kubectl -n labeler apply -f config cr.yaml unknown field labels. Okay, so again, okay, it is not, field name is not labels, field name is something else. Custom labels. You see, it should exactly match with the configuration we have. Okay, so the field name will be custom labels. Let's see if created. OC get LABE LER. Okay, it is created. Now let's see if there is any reconciliation done. Okay, so it is saying reconciling labeler, example labeler, which we just created, and then it says everything is done. Let's check if it is really done. Let's see if labels are applied. So what we need to do is label controller, the deployment we just created, and let's check the labels of JSON path.metadata.label, adding JQ in the end so that we will get a syntax colored output. So let's see. Okay, so we see environment is local, label manager is example labeler, and team is DevOps. Great. Now let's check it for other deployments as well, like if we are adding the labels on other deployments as well. So -a, and now we don't need the label controller here, and the syntax here will also change a little bit. Dot items star. So you see there are other deployments as well, and we are getting same labels getting applied. So this is all about today's exercise. We saw how we created a CRD, how we created a custom controller around the CRD, and then we created a custom resource for this CRD, and controller was able to read the custom resource and apply the labels in the deployment. Okay, so that's all. Now, as promised, I'll just walk you through once again with the reconciler and controller logic, because that is little difficult to understand when you are doing it for first time. But yes, it's not that difficult when you have the understanding of the concepts. So let's go with the main function is very simple. All we need to do is we from the main we call the shared main.main, and here we specify the component name, what is the name of your component, and then a new controller. It can be any number of controllers, like one controller we have, it can you can define any number of controllers that you want. Okay, so all those controllers will be registered. Now in new controller we have to specify like it will the syntax, sorry, signature of the new control function is context, and then it gives the voucher. If you are looking for like watching the resource called voucher, then you can utilize this parameter, otherwise you can just ignore it. So voucher, and then deployment informer we need, and then we need the label informer as well, and the kube client. Okay, the label informer will give us the information about the labels, deployment informer will give us the information about the deployments, and the kube client. Okay, kube client will be used to update the deployment. And once the reconciler object is created, we need to create a new impl object, new controller object out of it, and the controller object will be created via reconciler API. Import statement of reconciler is here, reconciler dot new impl context reconciler, and the function that we need to pause is like everything is standard. You can just like if we talk about this controller, you can just copy paste this controller without any hesitation. If you are looking for like some different logic, then you might need to change these two parameters. Apart from that, everything will remain same. Okay, now coming to the conciler. Conciler is the place basically where we have the business logic. The main business logic is inside the reconciler only. First, we define the structure of the reconciler object. It is basically the object that will hold what all we need. Kube client is required if you are going to perform any update operation on any Kubernetes resource, and informers we need if you need information about other resources. So right now we need the information about the labels and the deployments, so we are using two informers. Okay, and yeah, now in the reconcile, to use this as a reconciler, we need to implement the reconcile kind. The reconcile kind function will have the first parameter as the context always, and the second parameter which will be the custom resource. In our case, it is labeler, so it will be the labeler. Otherwise, if you are creating a reconciler for deployment, then you can create the deployment. Okay, and then it will return the reconciler of event. Create a logger. Loggers are important when you need to debug the error, just like you saw, like a program was not working at multiple stages, and by using the output from the logs, we were able to debug what is the problem with our logger. Okay, and then because we are going to apply these labels, like whatever labels we are specifying here, we need to apply those labels on a deployment. So what we have retrieved the list of all the deployments, and for this label we have created a patch data, and this patch data we need to convert this patch data to a JSON, and then finally we iterate through all the deployments, and in all the deployments we apply the patch. To apply the patch, we have context, deployment name, merge patch type, patch JSON, and patch options. Okay, this is how we specify. And yes, this is apply label. I'll add the comment here. Okay, and all this code is available in the GitHub repo we just created. So thank you very much. Hope you like this session, and whatever be your feedback, please let me know in the comments. I'll make more such videos on topic of your choice. If you want me to create any more videos on any topic that you want, just let me know in the comment. I'll try to accommodate your request as soon as possible. Thank you very much. Bye.